Hello, everyone, and welcome back to one of our next episodes in the Big Data series of webinars. My name is Jan-Willem Middelburg, and I'm going to be your instructor for today. And today we are going to talk about data inspection, data cleaning, and all aspects related towards making data tidy. One of the main topics that I've selected for today is tidy data. And at the end of today's session, I think you're going to be a little bit of an expert around how do you inspect and clean data in a very methodological and a very clear way. We're going to be basing this webinar on some of the main aspects that are coming from the theory around tidy data. And you will learn not just around the theory today, but I've also prepared a bit of a demo so that we can kind of roll up our sleeves and make sure that we have some hands-on experience throughout this part. Before we get started, just some quick notes. I've prepared a very short agenda for today. So as you know, or might not know, if this is the first time that you're joining, we are hosting and organizing these sessions as part of the Enterprise Big Data Framework series. So I always start with giving you a bit of an overview of how do you place this in the right context, where in the framework does data inspection and data cleaning fit. And if you've been watching some of our other webinars and videos, then you might start to see that we cover a different topic every time. So that makes it good to always place a very short session like today into the bigger picture. So I'll start with that. And then in the second part, I'm going to be discussing the main theory behind data inspection and data cleaning. I'm going to be showcasing you where the theory comes from. And the most important approach, what I've learned over the years, is that in order to do data cleaning and inspection well, it's always good to kind of find a methodological way. And what that we mean, making sure that every time that you look at a data set, whether it's completely clean or the dirtiest you've seen in the world, that you always follow the same process. As you gain more experience as a data scientist, that's basically one of your best practices in your toolkit. So today I'm going to share a little bit around what are considered good practices, and I'll also show you a little bit of what I typically do when I look at data sets. So that's the second part. And then after that, we are going to look at some data cleaning and practice. I've prepared a short little lab to illustrate some of the main points that we're going to cover today. So you can follow along and also afterwards keep practicing with these materials. For everyone who's curious, and I typically get these questions already at the start, we will share the slides as well as the links to the labs after this session. So there's no need to make screenshots or pictures while we are progressing, because we will make sure that you receive a copy of all of the different materials. Good. Then two other very small notes that I need to make. So please note that this webinar is always recorded. The recording will be placed on our social media channels, so you can watch it back at a later stage as well. And on the platform, I always very strongly encourage you to ask questions. That's one of the main benefits of using a live session like this. On the left-hand side, you will see a Q&A box and a chat function. My colleagues will be monitoring the chat for any immediate or urgent questions. And if you have any more in-depth questions for me or things you would like to see answered, then please use the Q&A function, so I will be able to moderate all of the questions in order of importance. So that's what we're going to look at in the next 35-40 minutes. Good. A little bit of introduction, especially for those of you who are new or for whom this might be the first webinar. Today, we are presenting some of the materials from the Enterprise Big Data Framework Alliance, which is an organization that advances big data best practices. So what are globally accepted standards and best practices that will make an organization data-driven. It's way too short time today to go into all of the different components of the Enterprise Big Data Framework, but in a very high-level summary, what you can see on the right is the 5 textbooks of the Enterprise Big Data Framework. And the material that we are going to be covering today is coming from enterprise big data analysis. So that makes a lot of sense because data cleaning and data inspection are very common operations, especially in the analysis of data. So that's what the material for today is going to be based on. At the bottom of this slide, you see an overview of the Enterprise Big Data Framework. So if you're completely unaware of what that is, then I strongly encourage you to go to YouTube and watch some of our previous videos. But the Enterprise Big Data Framework, very shortly laid out, is a capability model of 6 different organizational capabilities that an organization needs in order to become data-driven. And as I mentioned before, what I always like to do before we start diving in detail in any topic is to kind of give you a bit of an overview of the bigger picture. And what we are going to talk about today is a specific element, a capability, if you want to call it that way, within the domain of big data algorithms, which is the third core capability of the framework itself. In some other textbooks, this is known as data science, so it's very closely related. And within this capability, we're going to look at how do you extract value from data. So which kind of algorithms, which kinds of statistical operations do you need in order to transform enterprise data into a result that is actionable and hopefully predictive. So in order to do that, we're going to need to have a little bit more detail around the data set that we're actually going to analyze. So in case you're wondering, where does this fit? It's in the big data algorithms section. Good. Let me get started with giving you a bit of an overview of why data inspection and especially data cleaning is important. Both of these aspects are known as data preparation. And the reason it's called data preparation is because before we can analyze and say something valid around a data set, or before we can run an algorithm in order to make a prediction, we do want to make sure that the underlying data set is clean enough, that it doesn't have any faulty data, that there might not be any missing variables or values. The reason why that is important is for 2 main reasons. And the first is always the garbage in, garbage out rule. So if you cannot trust the validity and cleanliness of your data to begin with, then the outcome and the results and interpretations will also not be trustworthy. And the one thing that we would like to achieve in data analysis is to make trustworthy predictions. The second key part is that, as many of you might already know, is that specific algorithms have very specific details around how you need to feed data into the algorithm. So if you're using a classification or clustering or outlier detection, a standardized algorithm, then in many cases, they will only accept specific input types of data. So either categorical variables or numeric, and that will always be very clearly indicated within the algorithm itself. In many cases, that means that you will need to adjust your data set to match the input requirements of the algorithm. And that's also why data cleaning, data wrangling, as we're going to talk about also a little bit today, is going to be so incredibly important. And it's a big part of the job of being a data scientist. I always like to start any kind of discussion around data preparation with an article that you see right here from the New York Times. And that says that for big data scientists, the janitor work is the key hurdle to insights. And what we mean with this is that in the time that you spend on doing actual data science, around half to 80% of your time is being spent on making sure that your data is in the right format, that it's clean, that it's trustworthy. So that's a significant amount of time. The more interesting stuff, which is obviously model building, analyzing, visualizations, predictions, It's typically only a smaller percentage. So you see that this is a very significant part of what we're doing within the data science domain. Good, so basically we're all data cleaners. One of the main things that we're gonna start with, and I know that there's always a lot of confusion around this, is to kind of make a differentiation between data cleaning and data wrangling. And the definition that I'm going to be using throughout the webinar today and also in most of the other lectures is the definition which was an approach that was written down by Hadley Wickham, one of the pioneers in data science. And he wrote a very famous paper, I have a picture of that in some of the upcoming slides, around what would be good principles and good approaches with which you could review and make sure that your data is always in a predetermined format. That's exactly what I intend to share with you today. Is you need to really start thinking about a methodological approach. I know that many people will have their own way of looking at cleaning data, and that might be different from problem to problem. But what I'm going to try to convince you of in the next half an hour is that choosing a methodological approach, which is rooted in science and obviously in this case in white papers, is a very good best practice in order to analyze any kind of data set that you're going to be looking at. And in order to start with that, let me first of all explain the difference between what is known as data cleaning and data wrangling. When I'm going to be talking about data wrangling, which is going to be the second part of this webinar, we're specifically talking about how do you change your existing data into a new format. And so that often involves creating new records. So in many cases, you're doing this to fulfill the requirements of an algorithm, or you would like to make sure that data is adjusted. So for instance, in case we want to move from inches to meters, then that would be very clearly a data wrangling operation. Data cleaning, on the other hand, is the process of looking at data which is either incorrect or inaccessible, or that might be duplicate, contains errors. So data cleaning is more around changing your existing data set by either removing specific data or changing specific values, or even sometimes altering or imputing data to make it more relevant. There's a very fundamental difference between the two, and I always like to start with that because in practice I see that there's a lot of discussion and disputes around these two definitions, and people kind of use it interchangeably. In order to show you a methodological approach, the approach that I personally strongly would advocate for is the tidy data approach. And on the slide here on the right, you can see the cover of the actual paper, which was first introduced in 2013, so already a decade ago, and which basically outlines some fundamental rule to make data analysis easier and more structured. Now, I know that many of you probably don't like to read academic papers, but of all the papers that I read, this is probably one of the easiest to read and easiest to understand. I will provide a link later onwards to the white paper, but if you do a very quick Google search, you will also very quickly be able to find it. But the most important part is kind of a summary that is towards the end of the paper, and that is to consider a data set clean or tidy, as Mr. Wickham refers to it. It needs to adhere to three very fundamental, and I would say basic principles, but they're very valid to always keep in the back of your mind whenever you are considering or looking at a data set. And those principles are as follows. The first one is that you want to make sure that every variable is depicted in the form of a column. So meaning that everything that can change in a particular observation will be listed in a separate column. In practice, a lot of data sets will already be structured in that particular way. So for instance, if we are considering the year, which is an example that we're going to be using in our demo later today, we will see that this is structured typically in a column. In some data sets, however, you might see that a year has been spread out in specific columns itself, and that for every year there is a new column created. If that's the case, you might want to transform that to make sure that every variable that can change is assigned to an individual column. I will show you an example of that a little bit later. So if you're unsure around what a variable is or what a changing observation is, then wait until we reach the demo, and then I will show you a little bit more around that. The second main clean principle is that in order to process data correctly and fast, then we would like to make sure that every observation fits into an individual row. So in terms of computer science, these would be different objects or instances of an object will be listed in every specific row. So if we have multiple people, then we can list every new person as an observation in a particular row. And then last but not least, we want to make sure that every type of observational unit forms a table. And this is also one of the bases of good, I would say, database design, is to make sure that specific classes are implemented in individual tables. And that means that you don't start mixing up different categories within a specific table itself, but that you separate them. So for instance, suppose that we're making databases around all the animals in a zoo, then what we would like to have is a data specific table for, let's say, the giraffes and another one for the elephants, and we don't mix them up in the same kind of table itself. So that's a third key construct when it comes towards tidy data. Now let's look a little bit more at the practical aspects, because if you now have a bit of a better understanding of what is data cleaning and what is data wrangling, the key question then becomes, how are we going to apply that? The reality, and most of you are joining from a data science background will absolutely know this, is that most data sets that you need to work with do not adhere to at least one of the three rules. So either they have corrupt, missing data, the data might be spread out over different columns while it should be listed into observations, or the tables that you receive have been all put together and have basically a different purpose. So you would need to separate them into different tables. So that's the reality that we need to face with. So the question is, how do we move from a dirty data set and something that has a lot of data which we cannot immediately use in the right way? How do we move that towards a tidy data set? And some of the main operations that are used within data cleaning and data wrangling are listed here on the slide. And what I will do in today's session is that I'm going to focus mostly around data cleaning techniques, because that's the basis. And then in any of our subsequent webinars, I'm also going to talk about data wrangling. For the sake of time, because we only have a short period in a single webinar, it's impossible to do all. So I've made a decision for today to focus slightly more around data cleaning techniques, because that is typically where you need to start with before you can move on towards data wrangling. And that's going to make the purpose for today. So what we're going to do is that we're going to look at selection, filtering, arrangements, renaming, mutations, and data summaries. And with those techniques, I think everyone will have a good toolbox to tackle any kind of data cleaning exercise. In order to illustrate how data cleaning operations work and how you can look at data in a very consistent and methodological way, it's always best to kind of show it with some examples. So what I've prepared for today is a short demonstration which uses an open source data set, which is known as the Economic Freedom of the World. It's research which is done by Fraser Institute on a biannual basis, and it looks at how free specific countries are by looking at size of government, structure and security of rights, access to money, trade, regulations, credit, labor, and all kinds of other variables that are being consolidated ultimately in a score that indicates the freedom that people have in a particular part of the world. Based on 42 data points, a summary index is created, and this is published on a regular basis. If you just Google, again, economic freedom of the world, you're able to access the data. And after this webinar, I will also make this data set available as part of the lab itself. Good. Before we start moving to data cleaning, there is a best practice to always first do an in-depth review of your data. And that is what we refer to as data inspection. So before you even start thinking about data cleaning or data wrangling, the first question that you always brings to mind is, what am I actually looking at? What is it that we're reviewing? What is the data set under consideration? Because it matters a great deal whether you're looking at, let's say, 5,000 records or 50 million records. So you kind of want to start by reviewing that. Typical questions that you ask when you do the review are things like, do I have structured data? What is the format? How many variables are we talking about? Are the variable names clear? So do we have a good idea of what each variable means? And do we need to deal with missing values or not? In the data set that I prepared for you today, so the economic freedom of the world, there's obviously going to be missing data. So that's where we can discuss how do you deal with issues like that. So that's the first couple of questions. And in order to address that, in order to start with your journey of data cleaning and then ultimately data wrangling, it's generally a good idea to run through 3 basic steps. And those are the steps that you see here on the slide in front of you. The first step is to always review the structure of your data set. And that's going to be a very important step because that will give you an indication around what is the structure of the data that you're looking at. So are you talking about numeric, floats, integers, Boolean values, or any other specific data structure? Then the second step is to have a quick look at the top and the bottom of your data sets, because that will kind of give you an indication of if data starts to change over time. If you have very many records into the millions, then this might not be something that you can detect with your bare eye. But for smaller types of data sets, as you will also see in the case study example for today, there's quite a big difference between the start and the end of your data set. So that's why this is a very good practice. And then last but not least, it's to look at some of the summary statistics of your data. And by reviewing summary statistics, even before you start doing anything with your data set, it immediately is going to convey a lot of information around what you should be looking for and whether you can expect any quote unquote problems when you start reviewing and cleaning your data sets, especially when it comes towards things like missing values or corrupt values, etc. Good. So let me first of all show you these 3 steps in the lab that I'm going to show you at the end. These 3 steps are also clearly spelled out in code. And in these 3 steps, what I did for everyone is show the major structure both in R and Python. I know that there's Python lovers, I know there's R lovers, and I'm not going to start or settle the debate around which one is best. So in order to make things relevant for everyone, I see some people laughing in the comments. I'm going to keep it objective, and it means I will give you an overview of how do you do this both in R as well as in Python. So the key question that you would like to answer first is, what is the type of data that I have? And this ultimately comes back towards primitive types of data structures. And ultimately, that is having an impact around how data is stored on disk. I'm not going to bore you too much with that today, but it does matter from a processing point of view. And for that reason, also the algorithms that you're going to be using in order to extract value from data will need to consider primitive data types. So therefore, it's a very good practice before you do anything else in data science or start cleaning any kind of table, is to always first look at the structure of your data set. Many of you that are watching will already know that there are primitive data types like integers, floats, booleans, and strings. And before you start any kind of consideration, you really would like to convince yourself around what data types you're looking at. And I strongly urge you to really do this every single time, because a lot of these mistakes that you might otherwise make on later, in many cases have to do with your primitive data types, because you cannot see the difference with the bare eye. And the example I always like to use, if somebody types in a number but as a text field, so as a string instead of a float or an integer, then many of the machine learning algorithms that you can use will not accept it, and they will crash. And it typically will save you a few hours if you do this right up front, and then to typecast them into another primitive data type might save you a tremendous amount of hours. Good, so that's the first key thing to do. So here on the slide, I have an example. This one is going to be from R, and to kind of keep things fair, the demo today, I'm going to be using a Python example, but the basic idea is still the same. So what you can see right over here is that in this specific data set, there are a number of observations, 3,726 to be exact, and 36 different values. And what those 36 variables are going to be divided in is, for instance, the column name is going to be year, which we see right over here. And that column year will consist of integers. Those integers range from 2016 until late 2000s, as we will see in a second when we will look at summary data. The second column will be the ISO code, which is the country code. And that ISO code will be a categorical or factor variable that's called in R. In this case, with 162 different levels or categories. So if you ever need to build a machine learning or classification kind of algorithm, then this is very interesting information to have. And a little bit later, we are going to see the freedom scores. So the freedom scores are here given by economic freedom, which are going to be numeric. And then we have the rank. The rank indicates how free the country is, and that's going to be listed as integers. So right away here, you can see that there are different types of data structures. And right from the start, this gives us quite a good overview of what is the data that I'm looking at and how is it going to be structured. And for that reason, this is a very good best practice to start with at any time. So a couple of key things, what this tells us. What we can see on the previous slide, which I didn't discuss yet, is that this is a data frame. And for those of you who have a little bit more of background, will know this already, but a data frame is a two-dimensional structured data set that we could very easily manipulate. So think about it as an Excel sheet, but then in Python or R. So a couple of key observations that we have seen. Note that we have 36 different columns, 3,726 rows. We saw that the years are listed as integers, and that 2016 is the first one. We saw factor variables, which are categorical variables of 162 different factors, and that economic freedom was considered a decimal value or numeric value in this case in R. In the demo, which we're going to be doing next, I'm going to be showing you the exact same thing, but then in pandas data frame. The result is going to be exactly the same. So this is also to kind of show you that no matter which language you're using, the results will ultimately be exactly the same. Good, so that's step number one. And I strongly urge you to kind of keep that in mind. Always start with looking at the structure of your data set. Then step number two is to start to look at the top and the bottom of your data set. So I know that many people skip this step, but it will give you a lot of very valuable insights right from the start. So let me show you that with a very simple example of the data set that we looked at right now. And that is that the latest data year that we looked at in this data set is obviously 2016. So if I look at the head of this data set, I might think the first time that I see it, well, hey, this is a complete data set. There's a lot of data that I can actually analyze, because if I look at the head, I don't see any missing values. I don't see anything that I would need to clean or correct. Whereas if I then take the second step and I look at the bottom of the data set, meaning the last few observations, that's where you start to see a lot of missing data, a lot of NAs and a lot of elements that are not going to be present. So this is immediately an indication that in this data set, we obviously need to start doing some data cleaning because the information, especially from 1970s, is not going to be available in this specific data set. So right from doing that first step, even before I move to data cleaning, I will know that I would need to consider that. And then step number three is to look at summary statistics. So summary statistics are key indicators that are used to describe specific variables. And typically it will look at summary statistics on a column by column basis. Depends a little bit around what is the data type of your column. So obviously if you have strings, it's slightly more difficult than if you have categorical or numeric data. So by reviewing these summary statistics, it immediately gives or should give you quite a decent overview of what is some of the core information around the data set that you're looking at. Let me give you quite a little bit of an example. So here on the slide, you see some summary statistics for the data set that we have been looking at. And if I were to review the data set, let's say the column year, which we see right over here, then I can immediately see that this data set ranges from 1970 until 2016. We see that there is an equal amount of observations, or likely going to be an equal amount of observations for each of the different countries, which is again confirmed into this second column. And I can also do some numeric variables. So if we look at the economic freedom itself, it means that out of all the 3,600 and something observations, the average economic freedom for over all of the different countries is a mean of 6.5. The lowest score is close to 2 with 1.97, whereas the maximum score is 9.19. So again, this gives us quite an indication around the distribution of the data set, because especially if we consider that the interquartile range is somewhere between 1.5 and 7.3, it basically shows you that a score like 1.9 is really exceptional. So it also already gives you some indication around the shape and distribution of how your data is going to be dispersed. Again, if that doesn't tell you anything now, don't worry. This is something that we can very easily plot at a later stage. Good, so that's the third step, getting always a bit of a review of your aspects. As soon as you've done through this, and I've really tried to make this a habit. So whatever data set I'm looking at, I always follow these 3 steps, or even if I have looked at data sets before, because if you do that, it helps you to very quickly get a very basic understanding of what the data set is all about. In the second part of this webinar, I then would like to focus around 6 critical cleaning operations with which you can basically clean any kind of data set that you might have, especially when it comes towards removing corrupt, inaccurate records, or for instance, replacing data that is not valid or is not considered to be valid. The whole purpose of data cleaning is that at the end of data cleaning, we want to make sure that we have a data set which is consistent with other similar data sets that we are having in the system. So that also means that it's very organization specific. And in order to properly clean data, and I would like to highlight this, it means that you need to have some form of domain knowledge. So if you're looking at, let's say, research data from universities or for chemical processes, if you don't have any background, it's very difficult to make the right kind of assumptions on whether you are able to just delete data or whether you should fill it with other parts. So that's where domain knowledge plays a very critical role. Good. What I'm going to be doing is I'm going to show you some of the most common operators. I will go through some of these a little bit faster because they're quite straightforward. But I also prepared a quick lab, so that is going to help you to understand and practice with this afterwards. So I kind of want to give you an overview of this itself. The first element, and I always like to show these things graphically, is what is known as subsetting. And basically it means that we keep the columns that we're interested in. Subsetting is one of the most common operations in data science, and especially in big data, because as you probably will know, data translates towards money in terms of processing costs and storage costs. So the earlier you can narrow down your data set to only the information that you need in order to solve your business problem, the better it is. So I typically start immediately with subsetting columns that are necessary to reduce the data set to a smaller size. It's not just good in terms of processing, because it means you have to wait less time, especially if you have a large data set. It also means it will save you in terms of cost and storage. So that's a second main benefit. Subsetting means that you will select only the columns that you need. And in other words, it's going to look at the variables that are necessary for your specific problem. Good, that's the first one. The second key operation is filtering. So filtering keeps the rows that you want to have. Filtering is generally a temporary operation where we would like to only focus on a specific segment of the data. That segment can be, let's say, a specific year, which is going to be the case in our data sets, but could also be based on a specific key characteristic. So for instance, make it a distinction for all of the, in our data set, for all of the categories for a particular country, for example. Or for instance, what are all the countries that score below a certain number in terms of economic freedom? So filtering, unlike subsetting, can be based on specific conditions. So a condition could be, I would like to select all the countries that score lower than a 5 in terms of economic freedom score. Take this into account, because filtering is possible based on conditions, and with subsetting, which we just discussed, this is typically not the case. So that's a very fundamental difference between the two. Another key element is that, generally speaking, filters are more temporary to kind of look at a specific element in your data set, whereas subsetting is in most cases a more permanent data cleaning operation, because you're only interested in continuing with the variables that are of interest. So that's kind of a secondary main difference between the two. So in terms of visualization, it basically means that you only keep the rows and observations which are relevant for your particular business problem. Good. I think most people will be able to have seen this, especially if you have been working with Excel or other data science tools. And the third element is obviously data sorting. And with data sorting, we're trying to gain information typically around highest and lowest observations. So suppose that in the data set that we just looked at, we are interested in finding out which country has the lowest score or the highest, or if there is a particular year in which a country has a highest score. then we can use a sorting or arranging of data. So that's a very common operation in packages like Excel. This is basically already built in, and in Python and R, you also have already pre-programmed commands to do this very quickly. But looking at lowest and highest data sets is still, in many cases, a very crucial and critical operation that you would like to do. Good, then we get towards the third element. So remember the principles of tidy data, and that means that we would like to have every variable into the right kind of column. And in order to do that, you want to make sure that the variables actually mean something to you. So not just an X and a Y, or something that is completely understandable. So it's best practice to make sure that all the column names are understandable by the words. I like to use underscores to kind of give an overview of what the variable names need to look like, and gives me also a lot of rest if I look at very clean, well-named variables, because it immediately gives me an indication of what am I looking at, and understand that I don't make an accidental mistake with selecting the wrong kind of column. So renaming variables is very simple. So here on this slide, we see an example from Python. So here we are changing book value, which here has a space in it, towards book value as a camel case. And that will immediately change the value of the column. And that helps you tremendously, especially if you need to input columns later in specific machine learning algorithms. Good. Then let's move towards the next data cleaning operation. And the next data cleaning operation is either is called mutating, or adding new columns based on a specific condition. There's also always a little bit of a debate whether this is still data cleaning or is already considered data wrangling. But we refer here towards it as cleaning because it also gives us the opportunity to write over an existing column. And that, in that case, you could say that it's cleaned up your existing data set. So with mutation or adding new columns to your data, you can either add the new column to your data, which is what you see right over here, or in cases where you are very confident that your data needs to be changed underneath as well, you can choose to overwrite it with your data. I typically first add a column and then remove the other ones in order to make sure that the process is sound. But in some very quick cases, you could use to overwrite it, and then it really does become a data cleaning operation. Good, and then we move towards summarization. So summarization is going to make a summary of key data. And in many cases, it's going to be the same as or the equivalent of what's going to be a pivot table within Excel. So it's a quick solution to summarize and analyze data. In Python, this is going to be a group by operation, and it summarizes data based on a specific category. So for instance, suppose that we would like to have summary scores over all the years per country in our data set. Then we can make a summary of these data sets to immediately get an average score per country over all the different years. So that's a very useful operation as well. Good. So in the last, I see that we're already going very rapidly through the time. So in the last 30 minutes, we looked at the 3 key aspects of data inspection. And we looked at the 6 main aspects of data cleaning. So what I've done for you today, you know, for those of you who've been in my sessions previously, is that theory is one thing, but ultimately in big data and data science, you want to roll up your sleeves and actually do some things yourself. So what I prepared for everyone today is a bit of a lab demonstration. So let me share that with everyone on the screen, and then we can have a quick look at how this would work in practice. As I mentioned before, don't worry if you don't have access to this yet, because we will share everything with you later. so you will have access to the lab yourself as well as the slides. So let me share this window. Good, and I think this should be visible for now. Can I get a quick thumbs up from everyone if you can see the window, the browser? Perfect, thanks so much. So what I've done for you today is I made a slight variation of what is the Enterprise Big Data Analyst Lab 4, which is all around data inspection and data cleaning. So in this lab, you will first get the opportunity to import the data set. I've already done that. So here you can see the data set, which is a big CSV file, and that has been imported within the data set itself. So in this case, we're using Python. So for everyone who's unfamiliar with this interface, this is Google Colab. You can type in the link right here. And this is where you will get access towards a Colab environment. It's completely free to use as long as you don't use very, very large data sets. So by all means, I strongly encourage you to play around with this after the session today. So the first thing that you need to do, obviously, in order to start analyzing the data is to import it. So this is where the CSV package is going to be imported. And basically what we're doing is that we are importing the CSV file right here and assign it to a variable named data so that we can start to analyze it. I briefly wanted to talk you through the first 3 steps of data inspection. Remember that data inspection was first to review the structure of your data set, then looking at the top and the bottom, and then review the summary statistics. So within Python, this is all super easy. So the first step is that you just need to type in the word info, and that will give you immediately all the information that you need around your data columns. So here we see again that year is an integer, ISO codes are objects, which means categorical variables. Then we have economic freedom, which in this case is a float, and then all kinds of underlying variables, which are also all floats. Note that the info command will also give you immediately the number of non-null variables, so elements that are not missing. So by looking at your data set and doing this first operation, you can immediately see that, for instance, in marginal tax rates, there are going to be quite some values missing, almost 1,000 more missing than compared to the years. So that's a very strong indication that you need to do some data cleaning. Then the second step, I typically refer to them as step 2A, to look at the top, and then 2B to look at the bottom. So this is the exact same result as what we've seen in the slides. So it starts at the year 2016, and apparently it's listed in alphabetical order because it all starts with the A. But the first time that you might look at this data set, you might think, hey, this is very clean, everything is there. But if you then look at the bottom of the same data set, you will see that there's already a lot of missing values almost everywhere. So again, very strong sign that you probably need to filter out some of the older years, because those are the years in which a lot of data is actually missing. Good, moving then on towards step number 3. In step number 3, we're going to describe the data set. And again, see how easy it is, because this has all been built in. And in this built-in function, you will immediately see things like the count, the mean, standard deviations, minimum and maximum values. So again, what this shows you, if I just look at the year column, is that the minimum value of measurement is 1917, and that in this data set, 2016 is the last year in which we measure things. And again, if I look at economic freedom, it means that it ranges from a 1.97 to a 1.919. And no matter whether you're using R or Python, the result will be exactly the same. So those 3 steps, I hope everyone will take away as kind of a best practice on what you could use in order to make a very structural way to look at data sets. Good. Another good feature that is including Colab, which is this particular button, I kind of quickly want to show you. because it's immediately going to make also graphs of all of these data sets. So in case you're wondering, how do I quickly make beautiful graphs? Then this is a very quick way to do that. Kind of gives you immediately some of the elements and key summary statistics that you might be interested in. Good, then let's move to very quickly towards some of the data cleaning operations. I realize I'm almost out of time, so I'm gonna really speed this up a little bit. So what we've done for you is here to have all of those different elements listed as well. So for instance, in our data sets, we see quite a number of columns, but if you want to do analysis around economic freedom of the world, what you might be most interested in is the actual economic freedom scores. So what I've done in this subsetting exercise is to look just at what is the year, the ISO code, and the country code, and what is then ultimately the economic freedom score. So if you want to do a summary report, that might be sufficient, and it will greatly speed up all your processing. So by running that, I'm saving that into a data selected kind of variable. It kind of shows the elements, but then or only keeps the economic freedom scores for that specific element. Then filtering. With filtering, we want to keep rows based on a specific condition. So the example I used right here is to use a specific year. And in this case, the year that we are using is 2016. So if we do that, we will start looking at creating a new variable here, which is filtered df, and we're keeping the year. So if you look at doing that, we can see that there's 162 rows for the 162 different countries, and for all of those, the year will be 2016 because I've set this condition based on 2016. What I could also do is make it more of a conditional setting. So for instance, if I would like to do that, it needs to be larger than, let's say, 2010, and I run the same command, then it will show you everything that is above 2010 exclusive. So that means everything from 2011 or higher. Let me put this back because I will share the link to this lab with you later. I don't want to mess up any of the results. Good, then arranging very similar, and this basically means by sorting. So one of the main things that we might be interested in is obviously which country scores the highest based on this research and which one scores the lowest. So if we look at scores right here, we start to see that in 2016, based on this research set, economic freedom was the lowest in Venezuela, and it was the highest in Hong Kong, and followed by Singapore. So if we do the same thing, we might not just want to arrange based on from low to high. We also might want to do the opposite way. So it means we just put in another variable here, ascending, and say false, and then we get the same aspect from top to bottom. Good. So this is a bit of the lab, which will give you an overview. I will obviously send you the link after this, but I noticed that we only have 5 minutes left, and I do want to summarize a bit and answer some questions. So if it's okay, let me switch back towards the slides, and I will share the link to this Colab with you right after the webinar. Good. We're back at the slides. Good. Let me share that. I think we are back. Yes. So that was a quick lab demonstration of what you can do with inspection, cleaning, and wrangling. Couple of last remarks. So as many of you know, and who have been very loyal watchers on this webinar series, the content that I'm presenting today is part of the Enterprise Big Data Framework. And all of the books that are part of the core certifications are free to download. So in case you're interested in learning more around this, all the approaches around tidy data, the different data cleaning and data wrangling operations are explained in more detail in the free guides. So In case you want to study this in more detail, go ahead and download that. Second of all, if you want to get your credentials and up and would like to really have, I would say, a proven understanding of these methodologies, take some of the examinations. So the Enterprise Big Data Framework has partnered with APMG, and there is 9 different certifications and specializations that you can look into. The one that is relevant for today's session is obviously Enterprise Big Data Analyst. And that's something that you could take right after this course. Then thirdly, start communicating and being part of our community. So we have podcasts available. My personal one is called Big Data Days. And if you become a member, you will get access to that as well. And you can also find them back on YouTube and the Apple Podcast for any kind of free listening. Or sign up for Big Data Days. Every year we host a 2-day virtual conference with speakers from all over the world, 1,000 participants. It's a very great knowledge sharing event, and more importantly, it's free of charge. So that's also a good way to kind of gain additional knowledge. On our YouTube channel, you will find all the recordings of those sessions. So in case you really have a few days in which you would like to learn and watch a lot of videos, then I strongly recommend to go there. Last but not least, note that for everyone who takes the time to participate in our webinars, we very frequently have a quick giveaway. And same is true for today. So in case you're interested and you would like to get your certification, then based on the code that you see right here, you can get 30% discount based on the Enterprise Big Data Framework Alliance course. And this is including the examination. So it's a little bit too good to be true, but it is. Since these are only very special promotions for all of our webinar guests, note that this offer is only valid until this Saturday. So it's only 2 days. So in case you're interested, make up your mind quickly. We will also send you the link towards this afterwards. So if you could just click on this link, then it will automatically apply the discount code. You can find all of this on our Big Data Framework website. Good. Time for questions. We still have around 5 minutes. So I've seen a lot of questions come in, and I will start answering some of these. So first question is, where can we find the labs? So the lab is just a browser link, and in the follow-up email after this session today, we will make those the link to that lab available to everyone. That's the first question, and I hope that that answers that. Second question is, any tips on where I can find other data sets? There's a lot of very good open data sets available. You can look at opendata.gov, which is the US government data sets. Data.gov.uk is open data sets from the United Kingdom. Data.gov.singapore, so .sg gives you data sets from Singapore government. And other than that, there's a lot of other free data sets which are provided typically by tech companies. So Amazon has large data sets, Microsoft has large data sets. So in case you want to play around with that, there's a lot of good resources if you just Google open data sets. Then the third and fourth question are actually the same. I see is if I can share the link for the discount code in the chat. Yeah, I can do that, obviously. Give me a quick moment to fulfill that request. Here you go. I hope that that helps. I put it in as an image. That's not good. Give me a quick second. It's probably because it's listed on my slide. I can also get it from here. So this should give you the actual link itself is in the chat now as well. So I hope that that answers your question as well. Good, let me have a quick look. I think that means that I've answered everything for today. So you will get a very short evaluation after this webinar ends. So I hope you take the time to fill that out. Thanks for being with us again today. It's always a great pleasure to host this webinar for so many of you from all across the world. Thanks for your time, and keep a note of our schedule because we host these sessions very regularly. So if you want to learn something around other topics as well, I'm very happy to continue this series. Thanks so much for joining today, and I will see you again soon. Bye-bye.